Hello everybody, so I'm Denis. I'm responsible for Innoscience in Europe. Innoscience is the larger integrated device manufacturer for GaN-silicon power device, covering both low voltage and high voltage applications. Today what I have here is a multi-level converter meant to go to 850 volt by using 650 volt device. We use our 80 milliohm device to achieve 11 kilowatt. And the beauty of this is that it doesn't need any silicon carbide diode or snapper capacitor required for the high power. It has a system level cost optimization. It uses 3 level. And the beauty of it is that people always debate whether you can use GaN above 650 volt. So for that reason, people normally look at silicon carbide, 1200 volt. But actually the multi-level, and we are not the only one that are introducing this, actually allow you to go toward that application by using 650 volt device. We did this in collaboration with the BFH Institute in Bern, and they make this beautiful 3-level board where you can see our 80 millivolt device, one after the other, together with the driver. So we really believe that this one will open up for all sorts of applications from e-mobility motor drive, solar inverter, industrial application, and also EV charger or EV car eventually. Because it allows to, let's say, get to the 800 volt bus where people want to go. What I'm showing you now is a DC-DC converter, which has been sold, let's say, for data center. And what we can make in GaN is basically DC-DC converter switching at 1 megahertz. In this case, we use a 100 volt 7 milliohm device. The solution is very, very small. And this reach high efficiency and very high power density, or 2.2 kilowatt per cubic inch. We can also go to higher power, so 600 watt. In this case, we use, again, a discrete 3.2 milliohm 100 volt device. This is normally sold for data center, but can be used for industrial 48 volt bus, telecom, energy storage, or sort of those applications. And here you can see that you can already go higher than what you can achieve with silicon in terms of efficiency, which means saving in terms of energy. If we go to the ultimate solution, in this case we use an integrated solution that we call solid GaN. It's a 100 volt device, 3.2 milliohm alpha bridge integrated together with the driver. In this case we have like more easy to solder the device into the board, and we can achieve even higher efficiency because all the components are integrated in one package. We are not promoting the discrete solution or the integrated solution. We know that some engineers, they like the discrete, they make the system out of it. Some other, they like the integrated solution, so a full plug and play. So these one are perfect, let's say, for data center, very integrated and very powerful. So what we have here is a very high density PFC, 4 kilowatt in a very small form factor with a power density of 142 watt per cubic inch. And this one has been sold for data centers, so for the first stage of the conversion, going from the AC to the DC. But it can be used also for other applications, industrial power supply. So anywhere where you need high power, like 4 kilowatt PFC, this is a good solution. And it features our 650 volt, 30 milliohm device that are today available in engineering sample, and they will be available pretty soon. Next to that, we can also go for the full solution, which is a 2 kilowatt power supply unit, again sold for data center, very compact solution with respect to what you can do with silicon, and much more powerful than what you can do with silicon with the same form factor. Again sold for industrial power solution and etc. And thinking about data center, we reach 80 plus titanium type of efficiency, so going to a peak of 96% efficiency. Very small form factor. In this case, we use several of our 650 volt device, ranging from the 80 milliohm in a DFN to the 30 milliohm in a toll package, and also the 70 milliohm in a toll package. Both of these solutions are available in our website, so if you need more information, feel free to reach us out. Thank you.